Okay, so today what we're going to go over, we're going to go over our next chapter, which is chapter 2 into probability. So, for test, we're going to go over section 2.1, which is going to be sample, space, and sample like event. So an experiment, so as we define, I'm going to move this a little bit closer. An experiment is an activity where at least two outcomes cannot be predicted. So let's say an example of this, right? If these two outcomes not be predicted, right? Heads or tails, right? When we flip a coin, we're debating if it falls on heads or tails, and we can determine this with absolute certainty. All right, so our next definition is sample space. We can denote this by S, right? This is associated and listing all possible outcomes using set notation. So outcomes using set notation. So for example, let's say we have this going on the heads or tails example, right? S of sample space is either pure heads or tails. So using set notation. Last one, an event is any collection, or I'm going to say set of outcomes, right? So for example, we headed tails, so event A is heads, and event B is tails. So we can determine this. So as we move on, we're going to go into our set operations. So we can denote events going over A, B, and A complementary. All right, complement. So our first one we're going to go over is A complement. Right, A complement is all the outcomes in sample space. So in S, not in A. So if it's not an event happening in event A, but still in relation to it, it's going to be continued as complement A, since we don't want to call A. Second one, we have A union B. So this is what we call a union, right? That means all outcomes. Let me write this and write a little bit better. All outcomes that are in both A and B. Highlight this one because we have to make sure it's in both A or B or both. Third one we can call intersection. So as we write this, we can do it's A opposite sign, so instead of going up, it's going to go down, and B. This is all the outcomes in both A and B. So while before it was union of A or B, this is all outcomes of A and B. All right. Fourth one, we can write as disjoint or mutually exclusive. Right, so this one, what it is, it's still A intersects B, right, equals a set number or 0, right? That means no elements are in common. So we have nothing in common, right? So it's disjoint or mutually exclusive because we have nothing in common. Our fifth one, we have exhaustive. This is, right, A union B equals the sample space. So they include all outcomes of a sample space. our last one, what we're going to do, our last one, what we're going to do is called mutually exclusive or exhaustive. And exhaustive, where A intersects B equals nothing, and A union B equals S. So this is our combining, basically, 4 and 5, aka displaying, right, that no elements are in common, and they include all outcomes of the sample space. So I'm going to go over some examples as we move on as well too, right? So as we go down here, we're going to zoom in just a little bit. We're going to view some diagram examples. So you notice a complement is this, so anything that's shaded, by the way, like this, or sorry, better, like this, is our sample, all right? So a complement is all the sample space around here, but not going into A. So A is separate from the sample, so it's called its separate area. A union, right? Remember, we have A union B. What this is a combination, right? Combination of A and B. Intersection, right, as we go here, this intersects, right? So it's intersecting A of B, so it's the middle part of the diagram, right? As we move down to a more complicated one, A union B complement, right, is all the sample space over here, etc., but excluding that middle part right there. B complement A, where its sample space is in B here, but not in A. A union B, so all the sample space around, but not actually inside. A and B, so this is disjoint, not exhaustive, right? It's still the sample space, but they are separate, right? Exhaustive is a little bit of the following where it intersects, but you have both sample spaces. Mutually exclusive and disjoint, where A and B intersect, and A unionize B also in our sample space here. Okay. So as we went over a couple of these examples, right, we're going to move on just a little bit to our next one. All right. So our next one, we have 3 components to form a system that 2 and 3 are in parallel. So they're in parallel with each other as seen below. If the system of one works, then at least 2 or 3 will work. So let's say as we go through the system here, right? If 1 works, then it can either go to 2 or 3. The experiment records of the following conditions either the system succeeds, or the system fails. So the first one we're going to do, we're going to list all the outcomes of the sample space. So remember, every time we do an example, we're going to do it in red. So we have S equals, so since we have 3 points, so we have 3 possible outcomes, right? Possible outcomes of each thing. So our first one, number 1 succeeds, number 2 succeeds, and number 3 succeeds. So that's 1. Then we have number 1 succeeds, number 2 succeeds, but number 3 fails. We have 1 succeed, second one fails, third one succeeds, first one succeeds, second one fail, third one fail, right? We have the first one fails, second one succeeds, third succeeds, first one fails, second one succeeds, third one fails, right? You see where this is going. First one fails, second one fails, third one succeeds, and last one is all 3 system fails. All right, so this is our sample. All right, so as we go down, we're going to write all the outcomes for these following events. So event A is going to be at least 2 out of the 3 components work. So as we can do a little bit of example here, right? At least 2. So out of our sample space, I'm going to pick at least 2 of the components work, right? 2 out of 3. So we have S, S, F, right? Succeed, fail, succeed, fail, succeed, succeed. Since the criteria of this, S has to appear 2 out of 3 times, right, for us to denote A. B, we have a key word here, at least, right? So wording is very important in probability, right? We're doing at least 2 or 3 components, so 2 or more. So now our new sample space, we have succeed, 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 fail, fail, succeed, succeed, right? And then the next one, remember, as you're going from above, succeed, fail, succeed. So at least 2, so 2 or 3 or greater, right? So greater than that number. The system works, right? So remember the criteria above, where if 1 works, 2 or 3 will work. So C will equal, remember, succeed, succeed, succeed. All right, so we go back up and we look at if 1 succeeds, right? So we have 1 succeeds for our next one. And remember, our next one is succeed, fail, succeed, right? So succeed, fail, succeed. Awesome. Last one, only 1 component works. So now on this one, only 1 works. So as we go up, I'm going to look for only 1 success. All right, so that's 1. As I go up, 2. And the last one, remember, only 1 of them have to appear. As you go to number 3, are any events mutually exclusive or disjoint? Right? So the events are disjoint, right? Or that, remember, if we scroll up, we define disjoint as no elements are in common. So as we do the sample space, we're trying to look for, are any of our answers we gave, are any like a little bit connected to each other, right? So now we have the answer of C and D, right? We have none of them in C and none of them in D, so they are disjoint. B and D and A and D, right? None of them correlate with each other, all right? Next one, but this is going to be, I wrote on the wrong direction, over here, this answer. Nice answer over here, okay. Next one, we defined C complementary, A union C, A intersects C, B union C, B intersects C. So we're going over the first one, C intersection, right? So C complementary, remember, is all the sample space excluding the complement of C. So we can write down fail, succeed, succeed, because we're going to go into C. We're going to go into C, right? As we move on, we're going to succeed, fail, fail, right? That's uncommon. Next one is succeed. Sorry, not succeed. We had fail, right? So it's element of at least the system works. So every time the system fails, right? So fail, succeed, fail, 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 succeed, fail, fail, fail. We denoted this because the system, right? The system fails. Okay, next one, A union C, which means A occurs, C also occurs, or both occur in our sample. So this, we note this by fail, succeed, 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 fail, succeed, fail, succeed, and then succeed, succeed, succeed. So we're going off this with our question 2. All right. A intersects C. So now we're trying to find common elements. So this is going to be a little bit smaller. So as we go through our common elements, we notice that SSF, succeed, succeed, fail, and succeed, fail, succeed appears. B union C, remember, same rules that applies, right? So as we go N, succeed, succeed, fail, succeed, fail, succeed, fail, succeed, 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 right? then B intersecting C is succeed, succeed, succeed. So what are the common elements, right? It's SSS. So looking B and C, so SSS, SSF, succeed, succeed, fail. And then our next one, succeed, fail, succeed. Awesome. Okay, so as we move on over our next one, and then what we're going to do, we're going to leave this for 2.2. I'm going to add on to this for the next time we're in class, all right? So I hope you have a good day. Take care. Bye.